Okay, recording. So, today we're going to further our discussion about inverses. I don't think, why don't we look at this for just 1 second? I'm having a really hard time with that. Which one doesn't belong? Which one doesn't belong to you?
No, it's bottom right.
Bottom right? Why bottom right?
Because it's... Okay, I can't see that. But, because, like... Oh, wait, no, it's not. No, it's not. Actually, I don't know.
It could be any one of them, but you just have to back it up with a reason. Oh, it's not an inverse? Well, isn't it an inverse of this one? Right? Right? This one, right? This one is the inverse of this one. With an exception, we're going to talk about that later. You think this one is an inverse of which one? The top right? Yeah, that one is a direct inverse, right? Because that's the right of the parabola, and this is the positive part. Yeah, exactly. I'm going to argue this one for a certain reason. This one is the only one where y, the range, is positive infinity to negative infinity. This one, y has to be greater than 2. This one, y has to be greater than 2. And this one, y has to be greater than 2, right? That being said, what about this one? What about the domain on this one? X is also infinity and negative infinity, right? But in this one, x is greater than 2, right? Everything's to this way. And this one, x is greater than 2, and this one, x is greater than 2. So there's a reason for each one of them why you could pick which one doesn't belong, right? That's the whole point of which one doesn't belong. It's just what it means to you. We have a new family member! Yay! Our new family member is an inverse function. So our new family member has all the same traits as an old family member, right? The descendant. Only it's just going to be tipped on its side. Right? So that should make it pretty easy. Okay, can I get those computers closed? Because some of you are not even paying attention to what I'm doing. Fantastic, thank you. So we have a new member. So we better talk about the old members before we can talk about the new member. All right. So technically, I really don't need 5 coordinates to do a square root function. My vertex or my origin is always going to be at 0, 0. If I go over 1, I go up 1, 1, 1. And if I go to the left 1, I also go up 1. So negative 1, 1. Let's just lift this up just a little bit. All right. All right, that's all I need. Straight line. Let's look at the parent function of a quadratic function. We have 5 different numbers we would use on that one. We would start with 0, 0. We called these our magic numbers, remember that? Yeah. Magic. If we go over 1, if I square 1, I get 1, over 1, up 1. If I square 2, I get 4, over 2, 1, 2, 3, 4. And if I go in the negative direction 1 and I square negative 1, negative 1 squared is just 1, and negative 2 squared is 4. Gives. No. You can't. It can have imaginary roots, but as I'm plotting them, no, there's not going to be any imaginary. It can go down. How does it go down? How would I make a quadratic function point down? Put a negative in front of it. We're going to talk about that today too. Right? That's how we would point it down. All right. What about x cubed? What were our magic numbers for that? 0, 0. Right? If I cube 1, what do I get? 1. If I cube negative 1, what do I get? Negative 1. Right? Because a negative 1 times a negative 1 times a negative 1 is still negative 1. So if I put in a negative 1, I get negative 1. If I put in a 2 and I cube it, I get 8. 2 times 2 times 2 is 8. So over 2 up 8. And if I cube negative 2, I get negative 8. Negative 2, negative 8. And it looks like that. The last one is rational, our rational function. And the only reason I'm going to bring this up is because that one has a stretch on it. That's the only reason So first, before I do anything, my asymptotes would be 0 and 0. There is no vertical stretch. There is no vertical shift, and there is no horizontal, right? No shift. But there is a stretch of 3. Over 1, instead of going over 1, up 1, I go over 1, up 3. And instead of going up 1 and over 1, I go up 1 and over 3. Same thing in the negative direction. 1, 2, 3, 1, 2, 3. And I can write that by saying when x, instead of going over 1, up 1, I went 3 times. Does that make sense? Alrighty. Okay, so the next thing I want to do is talk about functions and not a function. Alright, my favorite function, not a function, is the example of a soda machine. So if I put $1 in the soda machine and I press Pepsi and I get Pepsi and a Diet Pepsi, is it functioning correctly? No. It's not functioning correctly, right? True. So I'm going to look at this one right here. I'm going to pretend like I'm talking about a soda machine. So I have an input and I have an output. So if I put in 5, right? If I hit, let's say Coke is number 5 on the soda machine. If I hit 5 and I get, what is this? 6 and negative 6. Do you see how that's not functioning? I put in one thing and I got 2 different outputs. This is not a function. Let's look at the other ones. Is this a function? Yes. Put in one thing, get one thing. Yes. Put in one thing, get 2 things. Not a function. What about this one? Nope. And this one? Yes. And this one? Okay. I really want you to think input, output, but the easiest way to explain this is with a vertical line test. You guys remember that? So vertical line test? Yes, exactly. Vertical line test means if I can draw a vertical line and I only touch the function once, or I only touch the graph once, then it's a function. Jonathan? So this one, it's touching twice. That's what makes it not a function. Alrighty? Okay. Caitlin. Super important stuff. Okay, so originally I was going to do this part of this discovery with you, and I figured, especially with the second day after the time change, and you guys are kind of dead, that we would have a we would have a hard time with it. So I'm going to go over it fairly quickly, and then I'm going to get you on Desmos and get you graphing real quick, and then I'll finish up my lesson. So I'm going to kind of chunk it. Okay. So these are my magic numbers, right? For a quadratic, 0, 0, 1, 1, 2, 4. So I'm going to go ahead and graph those real quick. 0, 0, 1, 1, 2, 4. With symmetry, there's my function. This is f of x. All right, list the coordinates of f of x as an ordered pair. So my coordinates are, I'm going to start -2, 4, then -1, 1, then 0, 0, then 1, 1, and then 2, 4. Is this a function? I know it's a function just by looking at it. But if I look at my ordered pairs and I look at all my inputs, do I have any repeating inputs? It never repeats, right? Yes.
So is the one that's like sideways, is that not a function?
Yeah, it's not a function. We're going to talk about that a little bit more. Okay, so a -2, a -1, 0, 1, 2. I put all different numbers into the soda machine, right? So I should get all different outputs, right? We're fine. Okay, so yes, this is a function. One input, one output. All right, if the coordinates were reflected across y equals x, if I had a reflection across y equals x, like we've been talking about, what would be the coordinates of the new image? Well, instead of -2, 4, my new coordinates at that point would be 4, -2. And my new one here would be 1, -1, 0, 0, 1, 1, and 4, 2. Graph the coordinates of the image is the image of function. I did this again. I want all of these to be, what do you think? Green. Of course, right? Green. There we go. Color coding. Okay, so my new function, it's kind of cool because you already know the magic numbers. They're transposed. So 0, 0, over 1, up 1, right? And over, instead of 2, 4, it's going to be 4, 2. 1, and which makes sense because the square root of 4 is 2. Right? We're thinking squares now, so over 1, 2, 3, 4, up 2. Technically, yes. Over 1, down 1. Over 1, 2, 3, 4, down 2. But when I take the square root of 4, I get plus or minus 2, right? I get a plus and a minus 2. But this part of my function right here makes it not a function, because it doesn't pass the vertical line test. So my new image, or I'm going to label it the inverse function of x. That's how we label it. Tell us it's the inverse of the other one. So the inverse is not a function. One input with 2 outputs. If I put in a 1, I get a 1 and I get a -1, so it's not a function. Which brings us to our next piece. What part of the original pre-image should we keep so that its inverse is a function too? Write this as a domain statement. So I would need to keep, let's do blue with the pink. So in order to make it a function, I would only keep the positive side. So I would only take the inverse of the purple one, and then I would get an inverse function. Now that's a function if I just keep the red part. Okay, so how would I put that? I would only take inverse of everything greater than 0 when x, right? Everything greater than 0. I'm going to take that. And that's going to make everything greater than 0 on the y-axis. Using the equation above, interchange x and y. I think I showed you guys this yesterday. So using the equation above, y equals, or f of x equals x squared. Interchange x and y and find the inverse function. Okay, to interchange x and y, I need a y. So y equals x squared. If I take the inverse of that, I get x equals y squared. In order to get rid of the square and solve for y, I need a square root, which gives me my newest member of the family, the square root function. Isn't it cute? It's our new function. That was pretty funny. Is that Melody? So my inverse function, this is how I would write it, is square root of x. It's our new baby. It's got a new set of magic numbers, 0, 0, 1, 1, 4, 2. That's it. That's all we use. Okay, you guys ready to go explore? All right, so what you're going to do now is you're going to explore what these transformations do. And you're going to notice that the transformations are very similar to every single transformation we've been using since the beginning of the year with H, K, and A. All right, to try and make some predictions on that. I'm going to go ahead and pause this and give you your discovery page. Recording? All right, I'm going to go through these really quickly. All right, so this is my parent graph. So it's just 0, 0, over 1, up 1, over 4, 1, 2, 3, 4, up 2. Magic numbers. What happens when I add a +2 to the x? It shifts to the left 2. Same magic numbers. Over 1, up 1, over 4, 1, 2, 3, 4, up 2. Just like if you had something like this. Remember this? Wouldn't that make my parabola shift to the right 2? Sorry, to the left 2? So it does it the same thing on a square root function. What about this one? If the positive 2 is on the outside, I would associate that with k, which is my shift up or down. Since it's not with the, whenever it's with the x, it's always the opposite, right? Because you set it equal to 0. This one's going to be up 2. So instead of being 0, 0, we're going to start up 2. Then my magic numbers are over 1, up 1, over 4, up 2. 1, 2, 3, 4, up 2. Lastly, this one has both. Has a vertical and a horizontal shift. So I'm going to go to the right 2, and then I'm going to go down 2. 2 transformations. Or I should say translations, because just translating is just moving, right? Over 1, up 1, over 4, 1, 2, 3, 4, up 2. Thumbs up, thumbs down. How are we doing so far? Awesome. Now we're going to talk about the A factor, or the stretch, right? How much we're going to stretch it. So if I have a 4 out in front, I don't have a vertical or a horizontal translation. I'm just going to make the graph stretch. So instead of going over 1, up 1, let's do this. Instead of going over 1, up 1, I'm going to multiply that by 4. So over 1, up, 1, 2, 3, 4. And instead of going over 4 and taking the square root of that and going up 2, I'm going to multiply that by 4. Right? My stretch is 4. So over 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8. So it looks something like that. The green one. Green one's a little different. The 4 is on the inside. So we could rewrite it as the square root of 4 times the square root of x, which is 2 root x. So now my stretch is in 4, my stretch is only 2. So I'm still going to stay at 0, 0, but instead I'm going to go over 1, up 1, but instead I'm going to double it. Over 1, up 2. Over 4, up 2. 1, 2, 3, 4. Instead of going up 2, I'm going to double it. I'm going to go 4. 1, 2, 3, 4. What happens if there's a negative on the outside? It's going to go down. Just like when we're talking about the parabola, if I put a negative on the outside, it's going to make it go, what? It's going to make it go down. It's going to make it frown. Right? So you're going to do the same thing if I put a negative out in front of this. So it's going to stretch, but it's going to stretch in the negative direction. So instead of going over 1, down 1, I'm going to go over 1, down 2, 3, 4, and instead of going over 1, 2, 3, 4, instead of going up 2, I'm going to go down 2, but I'm going to multiply it by 4. 2, 3, 4, 5, 6, 7, 8. Last one. Okay, this one, it's going to be, this one's a little bit more tricky. It's actually 2I root x, right? Yeah, it's going to switch to the negative quadrant. It doesn't technically have, like, imaginary roots, but so we normally would just write it like this, with a negative on the inside. So when the negative's on the inside, instead of it going to the negative, it's like taking the inverse of the negative side of the parabola. Does that make sense? So a parabola, when it looks like this, if I were to take the negative side of it, it would be this side, which kind of makes it confusing, right? That's the only one that is a little bit more difficult to explain. This one's the easiest one to explain, because it's like, if it frowns, then if you put the negative on the outside, it just makes it go down. So this one is still going to be at 0, 0, but instead of going to the right, I'm going to go left 1, and the stretch was 2, so I'll go up 2, and over 1, 2, 3, 4, up 4, 1, 2, 3, 4. It's stretched. Okay, so now what I think I want to do is I want to get into the part of the lesson where we're going to work backwards. All right? Because I think this is super helpful. So let's work backwards. I'm not even going to work backwards with this one. I'm going to work backwards here. Let's do this one. All right, so write the equation. F of x equals, this is a square root function. All right, so what's going on? What's my vertical stretch? Instead of going over 1, up 1, I'm going over 1, up 3. So I have a stretch of 3, which puts a 3 on the outside. Horizontal translation. Horizontal is this way, right? So we go over 1, 2, 3. So I would say, if I'm going to the right 3, it's going to be minus 3. No. It's always a minus, and when it's a plus, it's this. That's what makes it the plus 3.
Oh, I thought it was like that. Oh, never mind.
I think you're thinking the other way. All right, and so this, my vertical translation is going up 2. So this is going to be plus 2. You guys ready to do one for me? Get your whiteboards out. Go ahead and pause it. Pause. Do this one first. Yeah. Yeah. Recording. Okay, so first of all, I'm going to look at that stretch. My stretch, over 1, down 1. So it's going to be -1 or just a negative sign. So the stretch is negative. Negative. Going down in that direction. My x is here. Then my horizontal translation is over 1, 2, 3 to the right 3, which makes this a -3. And then my vertical translation is down 1. So it's going to be a -1 on the outside of the square root sign. If I were to put this on the inside of the square root sign, this -1, it's going to be x minus 4. If you put that in Desmos. Because you could check all these on Desmos, right? Make sure you're doing them correctly. Good. All right. What? Why is it -1? Because it's going in the negative direction. That's what makes it negative. Then on the negative on the outside makes it go down. Just like if you had a negative on the outside of x squared, it would make it go down. Yes, Jonathan? Yes. It's like the slope. Exactly. Okay. What about this one? Can we go forward? Let's do that one. Can you graph it for me? You guys have green graphs underneath your desk? What? Today? Oh, next week. Let me go ahead and pause it. One. Those of you that have it, have it. Those of you that don't, don't. You guys are really split right now. Okay, so my A, my vertical stretch is the 4. My horizontal translation is the 2, but since it's plus 2, I know it's got to be the opposite. So it's going to be going to the left 2. And my vertical translation is my -1 or my K, means it's going to be going down 1. So I start at the origin, and I'm going to go to the left 2. Then I'm going to go down 1. So that's my new origin, right? It's like my vertex. So from there, I need to stretch it. So normally when I square root 1, I get 1. But I need to multiply that by 4. So I'm going to go over 1, 1, 2, 3, 4. Normally when I square root 4, I get 2. 1, 2, 3, 4. Normally I get 2, but I'm going to take that and multiply it by 4. So 2 times 4 is 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's got a stretch of 4. One more thing I want to show you. Something like this is the hardest you're going to get. What do you notice about that? I can take a 4 out of there, right? This, I can pull out a 4 and I have x plus 3. Well, guess what? That quantity means I could take that 4 out, right? Because the square root of 4 is 2. I can simplify it. So this would really be, all right, I'm going to graph it, and then I'm going to pick a point, and I'm going to see if I'm right. This is what I would do if you were doing this on a test and you want to check to see if you graphed it correctly. You guys ready? So what I'm going to do is I'm going to shift to the left 3 and down 2, and I have a stretch of 2. So I'm going left 3, 1, 2, 3, down 2, 1, 2, and a stretch of 2. So instead of going over 1, up 1, over 1, up 2, over 1, 2, 3, 4, instead of going up 2, I'm going to go twice that, I'm going to go 4. This is how I check to see if I'm right. I'm going to use a table. So if I put in x into my function, which is 2, we can start with the original one. What was it? 4x plus 12? This is my y. Alright, which point should I try? This point would be the easiest one, or this one, or this one. Which one do you want to use for x? I would use the 1, 2. Put in a 1 for x and see if I get 2 for y. So if I put in 1 for x, I should get 2 for y. If x is 1, let's put a 1 in there. 4 times 1 is 4. We'll just do it. 4 with a 1 plus 12 minus 2. What do we get? Square root. 4 plus 12 is 16 minus 2. Square root of 16 is 4 minus 2. Do I get 2? So am I correct? I graphed it correctly. All right, that's all I have for you. Your turn.